The most important part of an electric vehicle is the battery. But if the battery stops working, you might end up needing to replace the entire floor of your car. That is not just an inconvenience. It is a major flaw that could create serious problems for the future of electric vehicles. But now, imagine a battery that is lighter than anything we have seen before. One that is so slim they could cut a laptop's weight in half, or make phones as thin as a credit card, while still powerful enough to boost an electric vehicle's range by as much as 70%. And here is what makes it truly different. It does not expand while charging, it does not grow dangerous metal spikes that cause short circuits, it does not bend or crack during impact, and it does not wear out quickly over time. What makes this possible? What exactly is this unusual new type of battery? Before we get into how this battery could help design phones thinner than a credit card or potentially increase the range of an electric vehicle like the Tesla Model 2 by 70%, let us first explore the structure of this unique battery. But before that, a quick welcome to our channel. This is AMP Drive. Our community is still small, with fewer than 1,000 early supporters, but growing fast. If this is your first visit, go ahead and hit that subscribe button and turn on notifications so you never miss our deep dives into the future of technology. Now, back to the breakthrough battery. At the Korea Advanced Institute of Science and Technology, also known as KAIST, researchers have developed what they call a high-density structural battery made from a special type of carbon fiber composite. Their approach is groundbreaking not only because of the materials they chose, such as strong carbon fiber and a solid polymer that allows ions to flow, but also because of the way they put it all together. Normally, the resin in these composites traps small air bubbles during the curing process, which weakens the structure and reduces its ability to store energy. The team at KAIST solved this problem using vacuum compression molding, a technique that carefully controls both temperature and pressure. This results in a cleaner final product with hardly any trapped air and a structure that offers strong mechanical support while also acting as a battery. What they achieved is significant. A 160% increase in the volume of carbon fiber compared to previous attempts. This led to a lighter and stronger composite that also stores energy. And this is not just an experimental design sitting on a lab bench. It can actually be manufactured using existing industrial tools, which means there is real potential for mass production. Meanwhile, on the other side of the world, a team at Chalmers University of Technology in Sweden, led by researcher Leif Aspie, has also been making major progress with another type of structural battery. Their design is a little different. They also use carbon fiber composites, but the carbon fibers play a dual role. They act as both the framework and the electrodes. A special structural electrolyte allows ions to move through a material that is as light and stiff as some metals. According to the Swedish team's early projections, these structural batteries could reduce a laptop's weight by half, make smartphones as thin as a credit card, or boost the range of electric vehicles by up to 70%. These are big promises and might even seem too optimistic. Still, they give a clear picture of what might be possible in the near future. Think about making a pie. You have the crust on the outside and a filling on the inside. Now imagine trying to make that pie lighter, tastier, and more nutritious all at the same time. You might start to wonder, why should the crust just be for holding things together? Why can't it be nutritious too? That is the basic idea behind these new structural batteries. By replacing both the car's frame and the regular lithium-ion battery with a carbon fiber structure that stores power while holding the car together, a typical mid-size electric vehicle could potentially drive up to 70% farther on one charge. Computer models show that current cars often use around 450 kilograms of metal bodywork and 500 kilograms of battery cells. These could be replaced by a structural battery pack weighing about 750 kilograms that provides 30 watt-hours per kilogram. Even though the new pack weighs more by itself, the car becomes lighter overall by about 200 kilograms because the traditional frame is no longer needed. The lighter weight and the extra space created inside the floor of the vehicle mean more room for power and longer driving range. And this same material offers exciting possibilities in smaller devices. For example, prototype laptop casings made from the same composite are as stiff as aluminum, about 70 gigapascals, while also storing enough energy to replace separate battery units. Since the laptop casing itself now becomes the power source, Chalmers engineers estimate that the total weight of a laptop could be cut in half without reducing battery life. For smartphones, the team built single-sheet battery cells only 0.8 millimeters thick that work as part of the phone's frame. Tech Radar has suggested that this could lead to phones thinner than 4 millimeters, basically the same thickness as a credit card. Between the first prototype in 2021 and the latest version from 2024, the energy storage capacity rose from 24 watt-hours per kilogram to 30 watt-hours per kilogram. At the same time, the stiffness of the material nearly tripled. Safety has also improved. The new battery design uses a semi-solid electrolyte and does not contain cobalt, which means it does not swell during charging or form the dangerous metal spikes that often cause shorts in traditional beige. Lithium batteries. So why are electric vehicle makers moving away from traditional lithium batteries? When people think about electric vehicles, they usually worry about how far the car can go, how long it takes to charge, or how big the battery is. But what if the next big leap is not about making a better battery, but about turning the car itself into the battery? That is the bold idea behind structural batteries, and it could change the way we design vehicles forever. Instead of focusing only on improving battery chemistry, these new batteries turn the whole vehicle frame into an energy storage system. That means instead of installing a battery inside the car itself becomes a battery. This may sound like science fiction, but companies like Tesla and BYD are already heading in that direction. Tesla has started using battery packs as structural components in the Model Y and Cybertruck. This reduces the number of parts and improves how the car handles and performs. At the same time, researchers and manufacturers all over the world are racing to create structural battery materials that are strong, light, and can hold a good amount of energy. Why are leading electric vehicle companies showing so much interest in structural batteries? It comes down to performance, efficiency, and freedom in design. Right now, electric vehicles carry large, heavy battery packs in rigid boxes at the bottom of the car. That adds weight and takes up space. But with structural batteries, you no longer need both a metal frame and a battery pack. They are combined into one. You could replace a 450-kilogram metal frame and a 500-kilogram battery pack with a single structure that does both jobs and still weighs less overall. The benefits go beyond weight savings. A lighter car uses less power to move the same distance. Some computer models suggest that structural batteries could help a mid-size electric vehicle drive up to 70% farther on one charge, just by cutting extra weight. It also reduces the cost per mile and opens up new design possibilities that were not available before due to heavy batteries and large support frames. Car companies are excited because this approach allows them to reimagine how cars are built. By merging the battery and the frame, they can create more interior space, make the car handle better, and potentially lower costs in the long term. Carbon fiber composites are at the heart of this progress. These materials are already popular in industries like aerospace and high-performance vehicles because they are strong and light. Now, engineers are discovering how to make them store energy too. By adding conductive materials and solid electrolytes into the carbon fiber, researchers are building structural batteries that are stronger and store more energy. Thanks to new resin technologies and vacuum molding techniques, these batteries pack more carbon fiber into a small space while avoiding the air pockets that normally weaken performance. At Chalmers University, the structural battery uses carbon fiber not only for its strength, but also to carry electric current as both the positive and negative parts of the battery. The latest version offers energy storage of 30 watt-hours per kilogram, still less than a regular lithium-ion battery, but a major improvement over earlier models. These batteries might not yet match traditional batteries in every area, especially for situations that demand high energy in a small space. But in many other cases, like when weight and space savings are important, structural batteries are extremely promising. Airplanes are a great example. Aircraft need to be as light as possible, and saving even a small amount of weight can have a big impact. Some research teams have already started building structural supercapacitors into wings and other parts of the aircraft. This shows that these ideas are not just theories, they are already being tested in real machines. Sustainability is another big reason for the interest in this technology. Structural batteries could reduce the need for raw materials by replacing several components with a single one that does multiple jobs. That means easier manufacturing, fewer emissions, and better options for recycling as the technology develops. Unlike many futuristic battery ideas still stuck in research labs, structural batteries are already being used in real products, even if only in limited ways. Tesla's move to a battery-integrated chassis is the first clear step in this direction and shows how structural batteries can simplify production and improve performance. But the technology still has challenges. To fully switch to structural batteries, manufacturers must solve problems like battery swelling, damage from impact, and long-term wear. In traditional battery packs, these issues are isolated. But if your car's frame is also the battery, any damage becomes a bigger issue. There is also the question of cost. Right now, structural batteries are expensive and hard to produce on a large scale. The special materials, complex vacuum forming, and precise layering techniques add to the expense. As with most new technologies, they will not become affordable until production can scale up, and that takes big investment and time. Still, interest from the industry is growing. As we see more real-world examples, innovation will speed up. Structural batteries are not just about better energy storage, they are about rethinking what a battery is. Instead of asking, how can we improve the battery, engineers are now asking, why should the battery be a separate part at all? That is the kind of thinking that leads to real change. So, would you feel safer or more nervous driving a car where the frame and battery are the same thing? Let us know your thoughts in the comments. Thank you for watching today's video from AMP Drive. If you liked it, tap that like button and share it with someone who loves innovation. And don't forget to subscribe and turn on notifications so you never miss what's next from AMP Drive.